So remember that the conditional is a statement of the form P implies Q. So if P, then Q. Now the converse is defined as the statement Q implies P. The inverse is the statement negation or not P implies not Q. And the contrapositive is the statement not Q implies not P. So let's do a quick example. Let's suppose we have a geometric figure, and I'm going to consider the conditional if it is a square, then it is a rectangle. Okay, so in this case, it is a square is my P, it is a rectangle is my Q, and so I've got a conditional here. The converse is the statement if it is a rectangle, then it is a square. The inverse would be the statement if it is not a square, then it is not a rectangle. And finally, the contrapositive is the statement if it is not a rectangle, then it is not a square. So this is just an example of a conditional and the three related statements, the converse, the inverse, and the contrapositive. So I want to say a word about the equivalence of these statements. The initial conditional, we know this to be true. If you have a geometric figure and it is a square, then it is a rectangle. If we look at the converse, if it is a rectangle, then it is a square. So this is definitely false. We know, so the converse in this case is false. So we already know that these statements are not equivalent. If we look at the inverse, if it is not a square, then it is not a rectangle. So we know that this is also false, because if you start with a rectangle like this guy, this is definitely not a square, but it is a rectangle. The contrapositive, if it is not a rectangle, then it is not a square. This is true because every square is a rectangle. So if you are not a rectangle, then you can't be a square. This statement is true, and in fact, contrapositive is always equivalent to the original conditional. Okay, so that's a really important thing. These guys are always going to be equivalent. In this particular example, the converse and the inverse were false, and they were not equivalent to the original conditional. That is not always the case. Let's do another quick example. For the following conditional, we want to write the converse and the inverse and the contrapositive. So the conditional is if x is equal to positive or negative 10, then x squared is equal to 100. So in this case, I'm going to say this is my statement P and this is my statement Q. In this case, the converse would be if I just flip Q and P around, so that would be if x squared is equal to 100, then x is equal to positive or negative 10. The inverse statement, remember that's the statement not P implies not Q. So that would be the statement if x is not equal to positive or negative 10, then x squared is not equal to 100. And then we have the contrapositive. And this is the statement, not Q implies not P. And that would be that if x squared is not equal to 100, then x is not equal to positive or negative 10. So remember that in the previous example, we saw that the conditional, the original conditional, is always equivalent to the contrapositive. However, in the previous example, it was not equivalent to the converse or inverse. So let's talk about that in this example. So the statement that if x is equal to positive or negative 10, then x squared is 100. This is a true statement, right? So we know 10 squared is 100, and we know that negative 10 squared is also 100. So if we look at the converse, if x squared is equal to 100, then x is equal to positive or negative 10. This is also true. Okay. If we square any other number, we're not going to get 100. We could even just solve this. If we just solve this as a quadratic equation. So let's look at the inverse statement. Is this true or false? If x is not equal to positive or negative 10, then x squared is not going to be equal to 100. And yet this is also true. Okay, so notice that the converse and the inverse could be true, or could agree or be equivalent to the original conditional, or they could be false. They could disagree. But the contrapositive will always be equivalent. This statement is always true, so this is always going to be equivalent to the original conditional.